Okay, so in this question we're told that there's a balloon and it's going up in height. It could be one of those hot air balloons, but let's say a normal balloon. And the height above the ground is h, and it goes up as time t goes ahead, as time t goes on. And we're told that the rate of change, or the change in altitude, is modeled by this function here, dh dt equals 1 over 2 plus t. Okay, so there are a couple of parts to this question. In fact, there's 3 parts to the question, and we can use a calculator for this. So it's just a matter of figuring out what the question's asking, and then we just plug the numbers into the calculator. Okay, so the first part of the question is find the height increase in the 5th second. Okay, so time is measured in seconds, and so what we want is the difference in height. So let me just call that delta h, and it's the 5th second, so it's between seconds 4 and 5. So we've already got the derivative, so what we want to do is anti-differentiate it, and for the 5th second is from 4 to 5. Okay, 1 over 2 plus t dt. Okay, and that's easy. Just plug it in the calculator, and you get an answer of, say, 2 decimal places, 0.15 meters. Okay, the second part of the question says the average rate of height increase in first 10 seconds. Okay, excuse my messy writing there. Okay, so what do we want here? So we want the average rate. So whenever you see average, it means that we're going to calculate the total and then divide over the interval. So it's going to be whatever the total is. So we're going to find out the height increase in the first 10 seconds and then divide it by, well, in this case, 10. Okay, so what's the height increase? It's a similar thing to what we just did. So it's the first 10 seconds, so it's from 0 to 10 of the function. Okay, and plugging that into the calculator gives us like 1.7918. And then divide by 10. So the average is, divide that by 10, 0.179. Okay, so let's say 0.18 meters, what is it in? Second. Okay. Okay, and then the third part of the question says that the initial height is 2 meters, and then find when the height goes first exceeds 5 meters. Okay, so in this case we're kind of doing it the other way around. So we know that in this case we know the change in height is 3 meters, and we just need to find when that's going to be 3 or greater than 3. Okay, so in this case we've still got the same integrals, so we've got from 0 to whatever, let's call it x, 1 over 2 plus t dt, and we want to find when that's greater than 3 meters, okay, because 3 meters is from 2 to 5. So when does that height increase be greater than 3? So the first thing you do is set it equal to 3, plug it into the calculator and solve it. You're going to get 2 answers in this case. We're going to get something like minus 42 point something, and what do we get? 38.17 approximately. So we can reject that one because this is a time interval, and so it can't be negative. So the answer is after let's say 38 seconds. It doesn't say how many decimal places we need, but that's going to be our answer.